Okay, hey, we're going to try a little different format this morning, and we're going to see how this works for everybody. Because I want to do a little bit of drawing, and so we're gonna see how that goes here. Um, what we are talking about today is position graphs um, versus velocity graphs. All right, and you might see it more as position versus time and velocity versus time. But the two are related, but it's important that we know the differences between the two. Okay, so I have the two graphs kind of drawn up over here. All right, on the left, this is our position graph. All right, we use X. Okay, so X as the displacement or its current position. And so if you are running away from me, he's at 20 meters, he's at 30 meters, he's at 40 meters, etc. All right, and then on the right, we have velocity versus time. Now, let's talk about how the two are related. Okay, so let's say we have a position versus time graph like so. All right, that's something we've been dealing with a lot. That person is moving at a constant speed away from us. All right, and it looks like the slope is 1 with whatever units we happen to be using. Now, what does that look like on the velocity versus time graph? Okay, that's kind of the question we need to answer. It's going to be moving away from us, and so it's positive. Is its speed changing at all? No, that is a constant speed. So that means it is moving away from us at a constant speed in the positive direction. So these two graphs are showing the exact same movement, just looking at different values. So this one's looking at the position of the object, this one's looking at the velocity of the object. Okay, let's take this same, oh boy, not that. Let's take this same graph over here, and instead of moving away from us, it's moving towards us. Okay, so now we have an object that's starting away and it's moving towards. We assign that a negative velocity. So our line's going to be about the same, only it needs to be below that x-axis. Okay, still moving at a constant speed. It's not increasing or anything like that. But it is now moving in a negative direction. All right, I should point out, may I have this one here? Let's say this position was up here, and let's say it was moving that speed. Okay, that's a much greater speed. That's a much steeper curve. And so this arrow on the velocity graph is going to slide down as a result. Okay, if it was a very gradual decrease in speed, this is going to be real close to 0 in there. Okay, last one. This is kind of a weird one. Oh my goodness, we got two different movements. All right, what's going on here? So this person's running towards us, stops, and then runs away from us. Instantaneously, mind you. That must be an impressive person there. So how are we going to do this? Well, there's clearly two velocities. So I'm going to have this first arrow representing that first negative velocity. And then this is where it gets tricky. That second arrow up here showing that, hey, at this whatever time, it is has a new velocity. Now, this is showing an instantaneous change in speed. We know that that's not true. We haven't said the A word yet, but we know acceleration is a thing. And so we'll have to deal with that bridge when we get there next unit. The last thing I want to leave you with is, what would a position graph look like for something like that? Something that starts off not moving and has an increasing velocity as it goes. Think about that for a minute. We're going to start off really close, and then as we start moving further away, our speed is increasing as we're going. And so we would have that's not a bad computer drawn line there. So we would have that increase in speed as we go there. Okay, but that's a problem for a different day. So position versus velocity graphs, know the difference between those two things.